So this example is going to show you the more difficult version of direct proportion. The same idea could have applied to inverse proportion as well. So we keep repeating it in the direct proportion first before the same idea is repeated in inverse proportion. So there are some steps to follow here. So you can try to follow the steps. Okay, there's an alternative method. Okay, we'll talk about the alternative method subsequently. Okay, so let's try to follow the steps. So in the first sentence, y is directly proportional to x squared. That already helped us with step 1. So that already helped us with step 1. Writing an equation involving y, x, and k. Okay, I need you to bear in mind something when you're doing this. So when you're doing this, right? Okay, I want you to bear in mind something. So when we say x squared, right? It actually means 1x squared. When we say x squared, it actually means 1x squared. So can it be a 2x squared? Can it be a half x squared? Can it be a 3x squared? Yes, it's totally possible. Okay, so that's our step 1. Step 2, the second sentence gave us y equal to 48 for a particular value of x. That means, right, we do not know the particular value of x, but we do know that it's actually equivalent to y is equal to 48. And you're not expected to find that particular value of x. So we're going to be doing the second step. I'm going to put in this value into my first equation. So I'm going to put in this value into my first equation. So instead of y equal to kx squared, that means right now kx squared is equal to 48. So that is essentially my second step. From my second step, we're going on to proceed to the third step. This is the step that differs from the usual one. So our usual question of direct proportion says that k is a value, usually is a value. But right now, if I carry on from step 2, my k is not a value. My k is an expression of x. It's like an algebra equation. So instead of usually getting a value for k, we get an expression for k. So with this basic setup, okay, we're going to answer the question. So when we answer the question, we got to be questioning here. So we want to find the value of y when this value of x is halved. So some people will be questioning, I don't even know what is that particular value of x. How am I going to halve it? So we're going to do it in a very generic way. So when x is halved, the idea here is, remember just now I mentioned about 1x squared. That means, right, 1x becomes half x, which also meant that usually the 1x squared will become a half x squared. And that also meant that y, instead of a 1x squared, it will become a half x squared. So instead of the 1x squared here, it will become a half x squared. Okay, so this is the time. Okay, so where is our fourth step? Let's take a look. Our fourth step is here. The new expression for x. So this is the fourth step. And we are going to put in our k. Okay, we are going to put in our k. So from here, let's take a look. The k will be substituted with this. Okay, so let me show you. K will be substituted with the formula. And what about the half x squared? The half x squared will be half x, half x. So from here, you slowly work out your algebra. Half times half will give you a 1/4. X times x will give you a x squared. That actually helps you to cancel. And you can punch calculator. So eventually, when we halve the x, y become 12. So let's take a look at the overall idea. That means, right, we started off with a particular x, and then y is equal to 48. And then when we decide to halve the x, y will become a 12. So the y value actually got decreased, like divide by 4, when the x value is divided by 2. So sometimes, right, a question will have asked you about the percentage change in y. So the question can ask you, if we will need the percentage change in y, that's quite possible. You take the new value minus the old value. Remember to divide by the new value, old value, and you actually get a percentage change. So in this case, right, you actually get a 300% increase. So that is the basic idea.